Hi, let's talk about the shipping box problem. We're going to take a right rectangular prism, so a bigger box, and we're going to pack it with smaller cubes. Remember, a cube is a type of rectangular prism, but it has the same dimension on all three sides. So a right rectangular prism, like a rectangle, the length and width could be different. So we have the length, width, and the height. But then we're going to pack it with cubes, and cubes have the same dimension on all sides. So let's just use whole numbers to represent the length, width, and the height to understand the problem. If you start with your shipping box, your right rectangular prism, and it has dimensions of 6, 2, and 10, and you want to pack it with cubes that have a dimension of 2 units. There's more than one way to approach this problem. We could start by seeing how many of these cubes will fit on each side of the right rectangular prism. So if I take my cube, how many can I put along the length of 6? How many cubes? If this cube is 2 units, each cube is 2 units, so there's 2 units, there's another 2 units, there's another 2 units, and we know that the length is 6. How many of these 2 unit dimension cubes can we fit along the length? What about the height? If the height is 10, how many of these 2 dimension cubes can I fit along the height? 2, 4, 6, 8, 10. How many was that? If I've got a width of 2, how many cubes can fit there? So what we're going to do is we're going to divide each dimension by the dimension of the cube. So if we've got a length of 10, 10 divided by the length of the cube, 2, is going to give me 5. 5 of these cubes will fit along the height. If we have a length of 6, 6 divided by 2 will equal 3. 3 of the cubes will fit along the length. And then if we said the width was 2, 2 divided by 2 is equal to 1. Only 1 cube will fit along the width. So now that we know how many cubes will fit along each dimension, we could use that and multiply to find how many cubes will fit inside the box. So if we were asked how many cubes are going to fit inside this box, knowing that there will be 5 high, 3 long, and 1 wide. So 3 by 1 means there's going to be 3 along the bottom, but then there's going to be 5 rows of that. So 3 times 1 times 5 is 15. That tells me the number of cubes. Now, those cubes, 15 cubes, each have a volume. What is the volume of a cube that has dimension of 2? Well, how do we find volume? We can use the volume formula, length times width times height. So if we're looking at the cube, the volume is 2 times 2 times 2, because each dimension is 2, or 2 to the third power, 2 cubed, if we were thinking about exponents. Either way, the volume is 2 times 2 times 2, which is 8. Well, if I know each cube has a volume of 8 units cubed, and there are 15 of them, well, 15 times 8 is one way I could figure out the volume of the shipping box. And 15 times 8 is... All right, now what's another way I could just figure out the volume of the shipping box regardless of the cubes? Well, of course, I could use the formula. Volume is equal to length times width times height. So 10 times 6 times 2, and that would give me the volume of this shipping box. 10 times 6 is 60, 60 times 2 is 120. So we see that 120 units cubed is the volume, the total volume of the box. And we can also get that answer by doing 15 cubes will fit that have a volume of 8. 15 times 8 is equal to 120. Could we have found the cubes needed? How many cubes are needed just using the volume answers? That's another way to approach the problem. Maybe we rather start with finding the volume, and then we could divide the volumes. 120 divided by 8 would have gotten me back to the number of cubes that would have fit in the box, 15 cubes. So we can see here that we have multiple approaches to finding that same information out about the problem.